Hey guys, Mr. Ing. Today we're going to be learning about regression lines. They also call this LSRL, which stands for least squares regression lines, or LSRLs. LSRLs. That's a shorter name, but we're just going with regression lines for now. What are learning targets? Learning targets make predictions using regression lines, keeping in mind the dangers of extrapolation. Learning target number 2, calculate and interpret a residual. And number 3, interpret the slope and y-intercept of a regression line. Remember, the word interpret is kind of like in context. What does that mean in the real world in that problem? Okay. So learning target number 1, what is the general form of a regression line? In algebra, for a linear regression formula, we would have used slope-intercept form. Y equals mx plus b. For stats, we do something very similar. We use y hat. You know, like it's sunny, you wear a hat. Put it on top of your head. This is called y hat. Let's write that. Y hat. And that formula is bx plus a. Or if you turn it around, but I kind of wanted to show you that the m part here is slope. Remember, slope is always with x, or in front of x, always with x. So it's kind of annoying when students will say, let's say the example is 3x. The slope is not 3x. The slope is just 3. It's the number in front. It's the coefficient. Okay. Another couple of ways to write slope is that it is the change of y over the change of x. Physics students, that is delta, so change in y over the change of x. And then our b, or the constant over here, this is going to be your y-intercept. So we're trying to connect it to algebra. The number in front of x is our slope, and then the number out there is our y-intercept. What is the difference between y and y hat? Well, y is, it is the actual y value from data given. And I'm going to highlight that it is the actual. Y hat is the predicted. Y value from the regression line equation. There it is. Okay. Okay, what is extrapolation? Extrapolation is using a regression line, and I want you guys to save some space over here. Let me try to draw it now. Draw a space. We're going to put a little graph in there. To predict outside the domain. Domain refers to the x value or the x-axis of the data that was used to make the regression line, to make the regression line. Okay, what does this mean? Let's say this is my data, right? And then here is your regression line. It's here in purple. And extrapolation is kind of outside of this red box. Data that goes outside this red box. What do you mean, Mr. Ing? That means if you try to continue on the trend line outside this red box, that would be information over here, or you're trying to say, well, what happened over here. Extrapolation. Okay, is it a good idea to extrapolate? Can't pronounce that one. No, because we cannot be sure. Oh, what happened? There we go. Whoa, sorry. Can't be sure that the linear trend continues. So back up here again, we're not sure that it's actually still a linear, the data looks as a linear trend. Okay. All right, let's do some examples here. Remember, learning target number 1, we're just trying to make some predictions. Okay. Example number 1. Based on the linear pattern, we want to predict the number of days after surgery it takes someone who is 30 years old to return to weightlifting. Use the equation of the linear regression. Okay. So you got surgery, and how long does it take you to go back to lifting weights? And here, look over days of recovery. It's a really big hat, right? Let me do this with this. Y hat equals negative 5.054 plus 0. That stuff shouldn't be there. 272x. Does that make sense? So there's a couple things that we can get from here. X equals 30 years of age, or since, let's write since 30 years of age, since 30 years of age. Okay? So if you put in a 1, no, 30 years of age. X equals 30 years of age. And then y hat is the predicted number of days. Let's write that. Y hat is the predicted number of days of recovery. After surgery. Okay, so there's my X. And we're going to put that in for age. Let's do that. Oh, highlighter. Y hat equals negative 5.054 plus 0.272 times 30. Right, we're making a prediction. Put on my calculator. So negative 5.054 plus 0.272 times 30 equals 8.16. And if you add those two together, you will get 3.106. Box your answer. Okay, so this is the hard part about stats, and so that's why I'm going to write a sentence. I need to kind of basically explain what does the 3.106 mean. We expect a weightlifter of age 30 to return to, remember, don't abbreviate on your quizzes or tests, weightlifting, WL weightlifting after shoulder surgery, which I've had before. In about 3.1 days. Let me give you guys a big idea of what this kind of looks like. We've been learning about scatter plots, and if I survey a bunch of people who are, how many days after surgery can they lift weights? This is the regression line, and then we're basically saying something like this. Age, because that's the x-axis, right? Y is days. And then we're kind of basically saying, well, if someone is age 30, what is happening there? And we're kind of figuring out over here on this side, number of days. Okay? All right. Example number 2. Let me read it and then you try it. Body weight and backpack weight. The data for body weight and backpack weight for 8 hikers was recorded, and the regression equation was given as y hat equals 16.26 plus 0.09x, where x is the body weight in pounds and y is the backpack weight in pounds. Go ahead and try 2A and 2B on your own. Press pause and then press play to hear me go over the problem. All right, what is the expected backpack weight for someone who is 200 pounds? So I'm going to write the equation again. Well, you're going to do it for both. Okay, color coding, this is where it helps, right? X is body weight. This is body weight. So for question 2A, what is the expected backpack weight? That's the question. Well, backpack weight, that means if this is a question, this is the unknown. So backpack weight is the Y. Whoops. Is the Y. That's what we're trying to figure out. That's the question. Okay? For someone who is, okay, so in translation, this means it's telling us that X in yellow is 200 pounds. All right, let's do our substitution. So I have y hat equals 16.26 plus 0.09 times 200. And if you do your math, you'll get the multiply that 0.09 times 200 plus 16.26. I just have to be a math teacher here. Don't forget, you can just put in your calculators, but you're really doing PEMDAS. I'm just highlighting that. Okay, you would never do 16.26 plus 0.09, then multiply 200. That's wrong. Multiplication, then add. Okay, put that in, and you'll get an answer of 34.26 pounds. Okay. Someone who weighs 200 pounds. Okay, remember in statistics, we're using these words that are like not certain. So we can say someone who weighs 200 pounds, we expect, remember it's not like 100% certain, the backpack to weigh 34.26 pounds. Okay? Let's try the next one. So, the question is, what is the expected weight of a person, of someone? Right? Is that yellow or blue? That'll be the, oops, hey, that'll be the yellow. Right? This one's going to be the unknown, who's carrying a 33-pound backpack. So the backpack is the y variable, which is y hat. So that's where I'm going to put it. So I have here 33 equals 16.26 plus 0.09x. Okay, I should have just shown you my trick that I use for PEMDAS. When you are simplifying, like we were in the last problem, you're going to go down on PEMDAS. But if you are solving, you go that way. Okay, what does that mean? We're solving right now, so I'm going to start with A and S. So addition, subtraction, that would be subtracting 16.26 from both sides. Again, I would assume you know that because this is your fourth year of math, but hey, I'm not going to leave it for chance. And if you do that, 33 minus 16.26, that gives me 16.74 equals 0.09x. And then we're going to divide both sides by 0.09. And we will get x to be 186 pounds. We expect someone weighing 186 pounds to carry a 33-pound backpack. That is a very big backpack. All right, let's move on to page 2. All right, we just finished page 1 where we're making those predictions. So learn target number 2, calculate and interpret a residual. So what is a residual? A residual, you might want to copy this also down if we go back in person to a formula sheet. Because formula sheets you can have, it is the actual, which is your y variable, minus the predicted. Predicted is y hat. Put a hat on it. Okay, so in some ways, that is the y minus y hat. That's what residuals is. Here's a silly way of thinking of it. Think we could have taken AP statistics, right? Which is actual minus the predicted. Just some silly way to help you remember it. AP. Okay. I don't know, I'm just thinking about like washing my car. So I wash my car, you intend to hit the soap on the car, and then when you're washing your car, there's soap or things that fall off your car. There's residual, that's like this extra parts, right? You had hoped that it landed on the car, but it came off. That is an example of residual. So how do you interpret a residual? It is the distance and direction. That the data point is from the regression line. Regression line's prediction. All right, since we just did the backpack problem, let's do it again. Well, that's my regression line. Let's make that more obvious. Regression line is purple. And then this represents all of the people's data points, okay? Right, this was, which one was X? Okay, person's weight. Person weight, and then the backpack weight, okay? And a residual is, let's think about this one, this red dot here, okay? This means that the person's weight, do you notice that the red dot is above the regression line? What does that mean? So it means that their backpack weight was actually over or more than our prediction. Let's do a different one. What color have I not used? Try this one. Nope. Nope. Okay, so let's just this blue dot, okay? This blue dot, based on the person's weight, we would assume that their weight, their backpack weight, but notice how it's below or under that purple regression line. So we expected them to be kind of like on the line, right? That's like the formula, but in statistics, everything doesn't like perfectly fall on the formula. So because this one's below, person's weight, their expected backpack weight is below what we expect. So I don't know, I'm just gonna make up a number. Let's just say that's 150, and then up here it is a backpack weight of 30. But because theirs is below, maybe they're carrying a 27-pound weight. Okay, so that's kind of like the big idea of residuals. let's try an example. This might make more sense. Example number 3. How much is that truck worth? Cars and trucks lose their value as soon as you drive them off their dealer's parking lot. So here's a formula. The predicted price is based off of miles driven. Okay, so I have a graph here. You'll notice that it has a negative. If I had to describe it, it would be kind of like suds, right? The shape is linear. Any unusuals, maybe a couple. Direction, it is going negative, and the strength, I would say the R value would be like a 0.8. Okay. All right, it says calculate the residual given a person paid $33,961 for a truck driven 68,474 miles. Okay, let's just write the formula down. Remember, if you 1, 2, you can do y hat equals $38,257 minus 0.1629. X will be for miles driven. So our price is this person paid this price. So let's put that number here. And then they drove the truck, that's green here. So they drove the truck 68,000 miles. So our predicted price in yellow. And let's just substitute that in there. So I have 30, why do I have to do that? $33,961. 38,257 minus 0.1629 times 68,474. Okay, so if you multiply negative 0.1629 times 68,000, and then you add that to 38,000, you know what? I made a mistake. This one shouldn't be there. Because y hat is the predicted, but they actually paid. Does that make sense? So this one should just actually be y. Okay. So you put those numbers in there, and then you get our predicted is going to be $27,103. Okay, so let's review. You basically bought a used car, and the formula is going to help us predict it. Okay, let's just even look. Let's look over here. Let's graph that order pair, 33,961. Somewhere around here, and then the miles, so 68,000. Okay, I'm just gonna do my best, okay? Okay, my point of intersection. This is the order pair. 33,000, 68,000. Okay, is this above or below? It's above. So I predict that this person overpaid for that car. Does that make sense? Okay. Let's do our residual formula. Residual is equal to our actual minus our predicted. Okay, what did the person actually pay for the car? 33,961. They actually paid for that there, right? Okay, then what was their predicted? Their predicted was $27,103. So their residual is $6,858. Okay, remember, is this positive or negative? It actually could be negative. Let me write a sentence, and we already kind of showed that it was above. So this truck costs $6,858 more because it's above than expected. Maybe you really wanted that car, you're going to go above the price based on its mileage. Based on its mileage. Okay? All right. You try college football, press pause, and then we'll go over this problem together. All right, college football. The SEC, I think that's the Southeastern Conference, has a regression equation of y hat equals negative 3.7506, blah, 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 where x represents the number of points scored per game and y equals the wins in a season. Calculate and interpret the residual for Southern California, that shouldn't say, they don't want to be Southern Carolina, that's South Carolina, who scored 30.1 points per game and had 11 wins. Okay? So let's calculate their expected. Let's write down that formula. Y hat equals negative 3.7506 plus 4.437x. Okay, so the first thing I'm going to do is x represents what? Points scored per game. So how many points do they score per game? They calculated 30.1. Okay. And again, we're trying to find the expected. And the expected is, we're trying to solve for this. So let's plug it in. Y hat equals negative 3.7506 plus 0.437 times 30.1 games per 30.1 points per game. And what we're solving for, the y hat, if you put that into your calculator, remember you're multiplying here first, then you're going to add negative 3.7506, and we're going to get we predict that they will have 9.40 wins. Well, then over here, we're going to calculate the residual. Calculate residual. Residual is the actual minus the predicted. The actual is they won 11 wins, right? And then the predicted is here. Let's put that in. So residual is 11 minus 9.4. So our residual, is it a plus or minus? It is a plus. 1.6 wins. Okay, because it is, I'm just going to make this obvious, because it is positive, is that above or below? That is above. South Carolina won 1.6 more games than expected based on the number of points they scored per game, right? We're kind of basically saying in this scatter plot, we predict that they will score this amount based on the number of points they scored. This is how many wins they should get, but in South Carolina, remember, they are above. Let's try page 3 now. All right, page 2, we just calculated and interpreted the residual learning target number 2. Learning target number 3, we're going to now interpret slope, or identify and interpret slope and the y-intercept, okay? All right, example number 5, salad at a burger place. At Math Burgers, each menu item was given with the amount of fat measured in grams and total calories. The following regression model was given. Okay, I'm just going to give it to you in advance, but basically what we're going to do next lesson in 2.6 is we're going to be able to calculate based off a table of values how to actually get the linear regression line. Okay, so something we're missing here is this one. Okay, so this is really y hat equals all this, and fat, as you see, is the x. Okay, identify and interpret slope and context. So if you need to, you can write your slope equation above this. Now, it's a little tricky. This one's changed up a little bit. You can do something like this, right? Totally fine. And we're trying to find slope. So slope is the number in front of x. So we could say the slope is 11.4. Okay, now this is in front of x. You go up to x is 11.4. 11.14. Let's try that again. That was a little messy. And I want to point out that you should write this as a fraction. Okay, so we normally like to write this one first. And that's just a unit of 1. Okay? So for every additional gram or 1 gram of fat, the model predicts approximately an additional, let's do blue. What does the y represent? The y represents calories. Additional 11.14 calories in the math food. Okay, so basically what I'm doing there is not just identifying, I circled it, but I'm also writing out what that means, right? And the fraction is super important because it's kind of telling you an additional 1 gram, so it's kind of weird. You can put a 1 there. That's the 1 here, right? Of fat. The model predicts an approximate additional 11.4 calories in the math food. Okay, let's identify the y-intercept now. The y-intercept is the one without an x. Okay. If the math burger, or the math food, if the math food contained no fat, right? Because if you put an x equals 0, if you made this 0, that 11.4 would go, right? Anything times 0 is 0, then you're just left with that. So I'm thinking like a salad. That's why I titled it Salad at a Burger Place. No fat, it would still have, how many calories? Still have 785.94 calories on average. Okay. All right. Going back to that car. How much is a truck worth? You press pause, you try the problem, and then we'll go over it together. All right, the equation of the regression line is shown. It tells me y hat. Okay, I like to write it right above. That's just me. And you can stick with the this formula here, and we need to find the slope. So what is the slope? Okay, remember, always change the slope to a fraction. Change of y over the change of x. Okay, now pay attention, this one is negative. Okay. So let's say, and then our x values, you know, are miles driven, and y is dollars. So because I know that now x-axis, so I can write for every, whoops, I should do blue because I'm doing the y's. For every mile driven, or 1 mile driven, then I'll do green. The price of the predicted price of the truck goes down by $0.1629, which is 16.29 cents. Okay, so I'm going to highlight something here. What happened to the negative sign? Well, that's why it is a negative trend. It's actually going down. So if you think about it, every time you drive that car, every mile, you're losing its value by 16 cents. Okay, identify and interpret the y-intercept. So the y-intercept is, of course, the number that does not have the value of x. So the y-intercept is 38,257. And what does that mean? Okay, so review math. Okay, so let's just say I pick this point right here. The order pair is 0, 45,000. So x is 0 and y is 45,000. So what would happen if I put in 0 right here? That would give me 0. So y-intercept is 38,257 is not the price, it is the predicted. Remember, that's kind of like the big idea. It's like the predicted price of a truck that has been driven how many miles? That has been driven 0 miles. Okay. All right, let's go on to the next page. All right, example number 7. You read it, you try it, and then I'll go over it with you step by step. Do cut flowers benefit from sugar in the water? Does adding sugar to the water in a vase help flowers stay fresh? To find out, 2 statistics students went to a flower shop and randomly selected 12 carnations. Those are the cheaper flowers. Remember, like, you know, during Valentine's Day when they're selling flowers at school, usually they give those and not the rose. When they got home, the students prepared 12 identical vases with exactly the same amount of water in each vase. They put 1 tablespoon of sugar in 3 vases, 2 tablespoons of sugar in 3 vases and 3 tablespoons of sugars in 3 vases. In the remaining 3 vases, they added no sugar. So trying to help you interpret, there's the 0. That's the no sugar. Those are the 3 vases. And this is the 1 tablespoon, right? And then here is the 2. And then this is the 3 tablespoons of sugar. After the vases were prepared, the students randomly assigned 1 carnation to each vase and observed how many hours each flower continued to look fresh. Here is the scatter plot with the regression line, y hat equals blah, 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 blah. That should have been a plus sign. Where x is the amount of sugar in tablespoons and y is the 5 hours of freshness. Oh, that one should be there. Briefly describe the association of the scatter plot. Okay, describe, you should be thinking of suds. Okay, what is our shape? Our shape is, looks to be, shape appears to be what? Linear? Anything unusual? No unusual observations, right? Or no unusual data points. What's D? Direction is positive. And what's our strength? Strength is strong, moderate, or weak. Strength is moderate. It's moderate. And then all of that is an association between, what do we have? Sugar and freshness. So that was a review question from previous chapter 2 material. B, calculate and interpret the residual for the flour that had 2 tablespoons of sugar and looked fresh for 204 hours. So let's write down our formula. Y hat equals 180.8 plus 15.x. Remember, x is the amount of sugar. Well, they want us to put in 2 tablespoons of sugar. So let's put in 2 tablespoons of sugar. And then y hat, you will get 15.8 times 2, and you add that to 180.8, then you will get 212.4 hours. Okay, positive or negative? It's positive, so let's calculate the residual now. So again, predicted, and then now the residual. Residual is the actual minus the predicted. So the actual was 204. Minus 212. So our residual is negative 8.4. What does a residual negative? Remember, it's below. So this carnation, or this flower, this carnation stayed fresh for what? 8.4 hours, more or less? Less than expected, based on how much sugar it received. What does that mean? It died earlier than we expected. Okay, interpret the slope and y-intercept for the regression line. Okay, remember slope is going to be a fraction. So I like to do the x first. The x first. Remember, over 1. And I actually like to write the word change of y over the change of x. And your x is sugar and y is freshness, right? So what color did I assign? X is going to be, we'll do blue. For each additional tablespoon of sugar, what happens? We'll do green. Or it's positive there. So the predicted, gonna underline that word, that's big idea. The predicted freshness of the flour, freshness increases. You have to have units here by 15.8 hours. Okay, so then what does the y-intercept mean? What does the x represent? If what? No sugar. If no sugar was added, x equals 0, then the, what do we write up here? The predicted freshness. Then the predicted freshness would be 180.8 hours. And 7D, would you be willing to use the regression line to predict the hours of freshness for a flour that received 10 tablespoons of sugar? So let's figure out what the 10 hours is. Okay, 10 hours is like way off the graph. Notice how it's outside of our graph. It's like way over there. And that's the vocabulary we learned. Extrapolation. No, this is extrapolation. We have no idea if the linear form or linear trend continues. What was our limit? Beyond, well, we only start with 3 tablespoons, so x equals 3 tablespoons. At some point, there will be, sorry, it's at the end of the page, I can't go up, will be, at some point there will be more sugar, think about this, than the flour can handle. Just like Halloween. All right, so that was lesson 2.5 regression lines. We made, let's just review what we did. We made some predictions, right? And we just did extrapolation. We can calculate the residual, and we can interpret the slope and the y-intercept. Thanks, guys.